Hey guys, welcome to the first lesson of math in 6th grade. So you should be watching this if you were absent or if you need extra help in this lesson. So this first lesson is going to take, and we are just going to focus on the greatest common factor. So we'll read that definition and we're going to fill in this graphic organizer here. By the way, when you watch these videos, you can pause it if you need time to write. You can rewind it if you need to hear something again or see something again. So keep that in mind. So first thing, it says a common factor is a number that is a factor of two or more numbers. The greatest of the common factors of two or more numbers is called the greatest common factor. That's confusing, so we'll break it down. We'll help you understand it in normal language. So first off, what does GCF stand for? Well, it stands for the greatest common factor. And now we're going to break down greatest common and factor, because if you understand these three words, you know what greatest common factor is. So let's start with at the bottom with what is a factor. Well, factors are numbers that go into a number evenly. So a factor is a number that goes into another number. And I'll give you an example. If I had the problem 2 times 3 equals 6, well, 2 and 3 are factors. They each go into 6. So that's what a factor is. They're the numbers you multiply. Common means the same. Think about it. If you have something in common with someone, it's something that's the same for both of you. And greatest, I hope you know, means the biggest. So let's put these all together. Factors are the numbers that go into another number, right? These are factors. The greatest or the biggest common factor is the biggest factor that is the same for two different numbers. And we'll show you on the next page. All right, so on the next page, here's what we're going to do. As I go over these examples, I'm going to go over example 1, and I'm going to go over example 2. These are two different ways to find greatest common factor of numbers. And once you are doing them, you can do any way you like. But we'll do both examples together and we'll practice both. So in number 1, this is called the list method. We list factors. All right, so let's start. This says there are 1 slice servings of 3 types of cake on a table. So here's our type of cakes: marble, red velvet, and chocolate. In number of servings, there must be 10 pieces of marble, 15 of velvet, and 20 of chocolate. Each row has an equal number of servings and only 1 type of cake. So picture that. If you have a row, they have to have the same number. So maybe you have chocolate, 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 marble, 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 marble. They have to be the same amount, and you can't mix them up in a row. What is the greatest number of servings in each row? So we're looking for the greatest common factor, the biggest number that goes into both. All right, now this method is good if you're good with thinking of all the numbers that go into something. So let's start with marble. Marble, there's 10 servings of marble. So we're going to list all of the numbers that go into 10. So we have 1 times 10, 2 times 5. They equal 10. We're going to do the same with 15. 1 times 15, 3 times 5. And with 20, 1 times 20, 2 times 10, 4 times 5. And then we look for the greatest one they have in common. And if you look there, you see 5 is the greatest. 5 goes into all 3 of those numbers, and it's the biggest number that does. So that means the greatest number of pieces of cake that can be placed in each row is 5. All right, so if you're good at listing them, you can do that way. Now, A, we're going to read together, and then you're going to try it that way. So in A, it says, Lana earned $49 on Friday, $42 on Saturday, and $21 on Sunday selling bracelets. She sold each bracelet for the same amount. What is the most she could have charged for each bracelet? So if she sold that much on those days, and each bracelet was the same amount, we're looking for the biggest number that goes into 49, 42, and 21, or the greatest common factor. So I'm going to start you off with 49. So let's start here. So 49, we're going to list all of the factors of 49. And I always start with 1 and itself, so 1 times 49. Now I leave them with space in between because as I get I like to write them working towards the middle. So 2 does not go into 49, 3 does not, neither does 4, 5, or 6, but 7 does. 7 times 7 is 49. And that's it. There's nothing between 7 and 7, so 49 is done. Now here's what you are going to do. In a second, you're going to pause this video. You're going to then find all of the factors of 42, that's our next number, and all of the factors of 21. And then circle the greatest one they have in common, the greatest common factor, and that's your answer. Now, here's what I want you to do. I want you to pause this video. You're going to do the problem on your own, and when you're done, then I want you to play it to see if you were right. All right? Pause it now. Go. All right, let's see how you did. So 42. I know 1 times 42. It's even, so 2 goes into it. 2 times 21. 3 goes into it. 3 times 14. 4 does not go into it. 5 does not, but 6 does. I know 6 times, let me put a comma there, and 7. I ran out of space, so I'm going to write a 7 right there. Okay, 6 and 7 touch each other. There's nothing in between them, so you don't have to go any further. Now 21, I'm going to start with 1 times 21. 2 does not go into 21, but 3 does. 3 times 7. And 4, 5, and 6 don't, so that's it. So do you see the biggest one they have in common? It's not that, it's not that, it's not that, it's not that, it's not that. So it must be 7. So that means your answer is $7. That's the most you could have sold each bracelet for. All right. You ready for the other method? This is the factor tree method. So if you didn't like method 1, you might like method 2. This is a way to use factor trees to find the biggest number that goes into both. So let me show you how this works. Now they have it done for you here, but I like to do it off to the side. So we're going to find the greatest common factor of 12 and 18. So just watch here. You don't have to write down because we'll do some together. So I'm going to start by doing a factor tree of 12 and 18. See if you remember how to do factor trees. So I'm going to break 12 down into 6 times 2. 6 can break down into 3 times 2. And 2, you just bring down. You can't break it down. I put a box around it when you get all your prime factors. In 18, you could do 6 times 3, but maybe I'll do 9 times 2. 9 is 3 times 3. And 2 you just bring down. So they're all the prime factors of 18. That's called prime factorization, by the way. So what do you do with those numbers? Well, you circle the twins. In other words, you're circling the common prime factors. Let me show you what I mean. So this 3 has a twin over here. This 2 has a twin over here. This 2 and 3 do not have twins. So you see the ones I circled, the 3 and the 2? You multiply them together. What's 3 times 2? It's 6. So that means the greatest common factor of 12 and 18 is 6. I'm going to write that down over on, oh, I don't need to write it down because it's an example. So if you do that, look at here, you see how the same thing was done here. All right. Now, let us work on B together. So let's start with B. We're going to do factor tree of 12, and we're going to do a factor tree of 66. So 12, maybe we'll do, I did 6 times 2 above, so let's do 4 times 3. Okay? And 4 can be split into 2 times 2, and then bring down the 3. So I have 2 times 2 times 3. And 66, always leave some space between your two trees. You could do 2 times 33, you could do 3 times 22. I'm going to do 6 times 11 though. And 6 can be split into 3 times 2, and 11, just bring it down. Okay, so we did our 2 factor trees. Now, look for the twins. Do you see any? Well, I see this 2 has a twin here. This 3 has a twin here. This 2 does not have a twin, and that 11 does not have a twin. So again, we have 3 times 2, or 6. So your greatest common factor equals 6. Okay? Now C, you are going to do this one on your own. Now I'll start you out. You're going to want to do a factor tree for 18, and a factor tree for 30. Okay, make sure you do your factor tree all the way and circle your twins. Now try this one on your own. Pause the video while you're doing it, and when you're done, just play the video and I'll go over it and we'll see if you got it right. Okay, pause it now. Okay, let's see how you did. So 18, you could do 9 times 2 or 6 times 3. So I'm going to do 6 times 3 this time. If you did 9 times 2, you should end up in the same spot as me. Now 6 is 3 times 2, and 3 I'm just going to bring down. So check your factor tree. Do you have 3 times 2 times 3? Now they can be in different orders. You could have 2 times 3 times 3, but you need those numbers. 30, I'm going to do 6 times 5. Again, you could do 3 times 10. You could do 2 times 15. 6, I'm going to split into 2 times 3, and I'm going to bring the 5 down. Okay, check your tree. Do you have a 2, a 3, and a 5? Now, how about twins? Did you find them? Okay, 3 is a twin, 3 is a twin, 2 is a twin, 2 is a twin, and these are not twins. Again, we have 2 and 3, so 2 times 3 is 6. We've had a lot of that same greatest common factor, but I know that's not the answer in D. Now, D, I'll tell you, is a little more of a pain in the rear end because the numbers have bigger factor trees. So this one can trick some people up. So again, pause the video. You're going to do problem D, and when you're done, restart it and see if you're right. Go. All right, let's see how you did, guys. So I'm going to start with 32. So 32, I'm going to split it into 8 times 4. 8, I'm going to split into 2 times 4. And 4, I'm going to split into 2 times 2. Okay, see if you got that far. Now, a lot of people don't realize you can split this 2 up, or 4 up into 2 times 2. But then I'm going to bring down that 2. And I'm going to bring down that 2. And I'm going to bring down that 2. So I have 5 2's. If you have 5 2's in the bottom of yours, you did it right. Now let's try 48. Okay, so 48, I'm going to split that into 6 times 8. I know 6 times 8 is 48. And 6 is 3 times 2. And 8 is 4 times 2. Now remember, this 4 I can split into 2 times 2. Bring down the 2. Bring down that 2. Bring down that 3. Okay, so that is how you factorize 48. Now, how about the twins? So, well, I see a whole bunch of 2's. So I see there's 1, 2, 3, 4 over here. So I could circle 1, 2, 3, 4 over here. And this 3 and this 2 are not twins. So what do? Well, I multiply those 4 2's. And I know 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. The greatest common factor is 16. All right. So they're the only problems you're going to be doing with me, but here is your job. Job is going to turn to page 10. And all you're going to be doing is 1, 2, and 3. It says find the greatest common factor of each set of number. Now, when you do this one, you can do any way you want. If you want to do factor trees, go for it. If you want to list all the factors, go for it. The main thing is you get the greatest common factor and show some kind of work to show me how you did it. All right, so do those, and if you are absent, I'll be checking those when you're showing me your makeup work. Okay, that's it for today. Thanks, guys.